Hi guys, let us move to the exercise 10.4 related to the vector product or the cross product of the two product. So in that first question we need to find the magnitude of vector A cross B, where vector A and vector B are given like this. So to find the magnitude, first thing is we need to find vector A cross B. How we are going to find the vector A cross B? It is nothing but taking our first row has I cap, j cap, k cap. Second row has the component of the first vector, that is 1 minus 7 7. You can see here 1 minus 7 7. Third row component of the second vector, that is 3 minus 2 2. Now I am expanding this determinant along the first row, that is I cap first row, deleting the first row and first column, that is nothing but minus 14 plus 14 minus j cap, deleting this row and this column, we are going to get 2 minus 21 plus k cap, that is nothing but minus 2 plus 21. So 14 14 it get cancels, so 0 I cap. 2 minus 21, it is minus 19, minus into minus, plus 19 j cap. Here it is again plus 19 k cap, but this is nothing but our vector A cross B. But what we needed, magnitude of vector A cross B. So how we are taking, it is nothing but square root of 0 square plus 19 square plus 19 square. So 19 square, it is nothing but 361 plus 361. So it is nothing but 2 times root 19. So this is the magnitude of vector A cross B. So the next question, find the unit vector perpendicular to each of the vector A plus vector B and vector A minus vector B, where vector A and vector B are given like this. So we need to find, understand the question properly. Here we need to find the unit vector. So that unit vector should be perpendicular to both vector A plus vector B and vector A minus vector B. So before finding that unit vector, we must know what is these two vectors. So with the help of vector A and vector B, let us find what is vector A plus vector B. So vector A plus vector B, it is nothing but 1 plus 1, it is 2 I cap, 1 plus 2, it is 3 j cap, 1 plus 3, 4 k cap. So this is vector A plus vector B. Then vector A minus vector B, it is nothing but 1 minus 1, 0 I cap, 1 minus 2, it is nothing but minus j cap, 1 minus 3, minus 2 k cap. So it is nothing but minus j cap minus 2 k cap is nothing but vector A minus vector B. So while I am explaining the cross product itself, I have said that is nothing but if vector A and vector B are two non-zero vectors, means then vector A cross vector B, it will be in the, so if this one is vector A, this one is vector A and this one is vector B, means then their cross product will be in the direction perpendicular to both vector A and vector B. That is nothing but right hand thumb rule. So that n cap or vector n, it is perpendicular to both vector A and vector B. So now here we need a unit vector perpendicular to both of this vector. So how we can find a vector perpendicular to both of that vector? Just by taking the cross product of two vectors, the resultant vector what we are going to get by the product or by the cross product of these two vectors is nothing but the perpendicular vector, which is perpendicular to both vector A plus vector B and vector A minus vector B. So vector A plus vector B cross vector A minus vector B, it is nothing but I cap, j cap, k cap, first row. Second row component of this vector, that is 2, 3, 4, and third row component of this vector, that is nothing but 0, minus 1, minus 2. Now we know that cross product will give us again a vector quantity. So the cross product of these two vector will we are going to get a vector. So now I am expanding this one along the first row, that is nothing but I cap minus 6 plus 4 minus j cap, it is nothing but minus 4 plus 0 plus k cap, it is nothing but minus 2 plus 0. So here minus 6 plus 4, it is nothing but minus 2 I cap minus 4 j cap minus 2 k cap. So this is nothing but our vector A plus vector B cross vector A minus vector B. So I'll call this vector as vector C. I'll call this one as vector. So this is our vector C. So this vector, whatever I got this vector, it is perpendicular to both vector A and vector B. So we got a perpendicular vector for both vector A plus vector B and vector A minus vector B. But what we required? We required unit vector. So take the unit vector of that vector. So how we are going to get unit vector? That is nothing but C cap is equal to vector C divided by magnitude of vector C. So that is nothing but minus 2I cap minus 4j cap minus 2k cap divided by square root of minus 2 square plus minus 4 square plus minus 2 square. So it is nothing but minus 2I cap minus 4j cap minus 2k cap divided by square root of 4 plus 16 plus 4, it is nothing but square root of 24. I can write it as square root of 4 6 are 24, it is nothing but 2 root 6. So what happens to this one? Minus 2 by 2 root 6 I cap minus 4 by 2 root 6 j cap minus 2 by 2 root 6 k cap, where 2 1s are 2 2s are 2 get cancelled. So it is nothing but minus 1 by root 6 I cap minus 2 by root 6 j cap minus 1 by root 6 k cap. It is nothing but the unit vector perpendicular to the each of the vector A plus B and vector A minus B. So if you didn't get this one, please go through this second question what I am explained. Go through it again, you will come to know it clearly. So there is similar type of question like this one in your exercise second question. Try to solve it yourself. Second exercise question, try to solve it by yourself, because I have did this one from the example one. So try to solve that second exercise question by yourself. So the third question, which is some bit interesting question from out of all those your exercise questions. So you can see here, if a unit vector A makes an angle pi by 3 with I cap, pi by 4 with j cap and acute angle theta with k cap, find the angle theta and hence the component of vector A. So in the solution, first thing, vector A, it is a unit vector. First thing, a vector A, it is a unit vector. So this vector, suppose if I am taking x, y, z 3-dimension axis, and this one I am considering it as a vector A, which is a unit vector. So this makes an angle pi by 3 with I cap. So I cap, it is a unit vector along x axis. So this vector makes an angle pi by 3. So a vector making an angle with the pi by 3, it is called as alpha. Here alpha is pi by 3. So pi by 4 with j cap. So j cap, it is lying along the x axis. So the vector making angle with j cap means it is making an angle with the y axis. So the angle which is made by the vector along with the y axis, it is nothing but beta. Here the beta is pi by 4, and theta, it is nothing but acute. So the angle is lying between 0 to 90 degree. So this is the acute angle. So theta, it is nothing but our gamma, which is making it with an angle with the k cap, which is nothing but a unit vector along the z axis. So here we are having alpha, beta, gamma. So what about cos alpha? It is nothing but cos pi by 3. So cos pi by 3 is nothing but 1 by 2. What about cos beta? It is nothing but cos pi by 4. It is nothing but 1 by root 2. So what about cos gamma? It is nothing but cos theta. We need to find the value of this theta. So why I took now this cosine of the given angle? Because we know the relation between the unit vector and the cos of the cosine of the given vectors. Cosine or value of the angles of the given vector. That is the component of the vector A. Here the vector A is nothing but the unit vector. So the component of this unit vector A is given by what? Cos alpha I cap, cos beta j cap plus cos gamma k cap. As we all know that the cosine of the angles is nothing but the unit vector, which I have already said in the beginning of the vector algebra concept. If you have forgotten that one, please go through that video and clarify your doubts. So the component of the unit vector can be given in this way, that is cos alpha, cos beta and cos gamma k cap. So we know that magnitude of vector A is equal to 1. Since it is a unit vector, the magnitude is always 1. So this is the component of a vector. Now if I take magnitude of vector A is nothing but square root of cos square alpha plus cos square beta plus cos square theta. This one is 1. If I am taking square on both the side, it becomes 1 square. Square root square get cancels. So here it is 1 square cos square alpha plus cos square beta plus cos square theta. So what is cos alpha? It is nothing but 1 by 2. So 1 by 2 square. What is cos beta? 1 by root 2. So 1 by root 2 square. Cos theta is cos square theta is equal to. So here we are having 1. So 1 by 2 square is nothing but 1 by 4. This is nothing but 1 by 2 plus cos square theta. 1 by 4 plus 1 by 2, it is nothing but 3 by 4 plus cos square theta. So 1 minus 3 by 4 is equal to cos square theta. It is nothing but 1 by 4, which is equal to cos square theta. Clearly cos theta is equal to square root of 1 by 4, which is nothing but 1 by root 2. Here we are taking the positive value because here they have said theta is the acute angle. So theta, it should be lying between 0 to 90. If I take the negative value, we are going to get the obtuse angle. So I am taking only positive value. So cos theta is 1 by 2 means theta is cos inverse of 1 by root 2. What will be the angle? Cos inverse of 1 by root 2 means it will be nothing but pi by 3. So now we got the theta is equal to pi by 3, and therefore component. What is the component of vector A? It is nothing but, as I said here early itself, cos alpha I cap, cos beta j cap, cos gamma k cap. So what is cos alpha? It is nothing but 1 by 2 I cap. What is cos beta? 1 by root 2 j cap. What is cos gamma? It is cos theta. So cos theta is pi by 3. So cos pi by 3 means how much? It is nothing but 1 by, it is 1 by 2. So it is nothing but 1 by 2 k cap. So this is nothing but the component of vector A. So I'll briefly go with it once again. Here they have given us the respective angles, that is alpha, beta, gamma. So we need to find this theta angle, that is nothing but gamma angle. First we are taking the cosines of the given angle, and we already know the relation between the component of the unit vector and the cosines of the vector. So that is cos alpha I cap, cos beta j cap, cos gamma k cap. It is nothing but the component of the unit vectors. And we are going with substituting, finding the magnitude of the unit vector, solving LHS and RHS simultaneously. By solving that one, we are going to get the angle theta. So once we get the angle theta, substituting that value, taking the cosine of that theta, we are going to get cos gamma. Once we get cos gamma, we can write it the component of the given vector. So this is regarding the third question. Here is the next question, that is vector A minus vector B cross vector A plus vector B is equal to 2 times vector A cross vector B. We need to show this one. So I will consider the LHS, that is vector A minus vector B cross vector A plus vector B. First I will multiply as usual, that is vector A cross vector A, multiplying this one with these two elements, again this one with these two elements. So vector A cross vector A plus vector A cross vector B. Now multiplying this minus vector B cross vector A minus vector B cross vector B. So we already know that vector A cross vector A is equal to 0 vector. Similarly, vector B cross vector B is equal to 0 vector. So clearly what happens? This becomes our 0 vector. So what is remaining? These two are remaining. And we also know that vector B cross vector A is equal to negative of vector A cross vector B. So vector A cross vector B I will retain as it is, minus as it is. So vector B cross A is nothing but what? Negative of vector A cross vector B. So what happens? This one as it is plus vector A cross vector B minus into minus plus vector A cross vector B minus 0 vector, where this one get cancels. So what is remaining? This is nothing but 2 times vector A cross vector B, which is nothing but our RHS. So this is how we are going to show or prove the given result. So here is the next question. They have given you the cross product of two vectors is equal to 0 vector, and you need to find this, what is the value of this lambda and mu. So they have given you cross product. So what is that? We know that cross product of two vectors means how we are writing, we are expressing it in the determinant form. First row I cap, j cap, k cap. Second row components of the first vector, that is 2, 6, 27. Next is component of the second vector 1 lambda mu, which is equal to 0 vector. 0 vector means what does that implies? It is nothing but 0 I cap, 0 j cap, 0 k cap. Now I am expanding this one along the first row. That is nothing but I cap 6 mu minus 27 lambda minus j cap. It is nothing but 2 mu plus 2 mu minus 27 plus k cap. It is nothing but 2 lambda minus 6, which is equal to 0 I cap, 0 j cap, 0 k cap. Since two vectors, this one is equal to this one, then the two corresponding components are equal. So now comparing the corresponding components, we can write 6 mu minus 27 lambda is equal to 0, calling it as equation 1. Then minus 2 mu minus 27 is equal to 0. Then calling this one as equation 2. The next is 2 lambda minus 6 is equal to 0, calling this one as equation 3. So by looking into equation 3, what happens? If I solve equation 3, 2 lambda is equal to 6. Therefore lambda is equal to 6 by 2, which is nothing but lambda is equal to 3. So I got the value of lambda. Similarly, if I solve this one, first I will multiply that minus sign inside. 2 mu plus 27 is equal to 0. So minus 2 mu is equal to minus 27. Minus minus get cancelled. So value of mu is 27 by 2. So we got the value of both lambda and mu. So they asked us to find what is the value of lambda and mu, and we got the value. That's all. Here this is one of the beautiful and interesting question in your exercise problem. So they have given you the dot product of any vector A and vector B is 0, and the cross product of the same two vectors is equal to 0 vector. Then if these two are happening means what we can conclude regarding vector A and vector B. We should give the conclusion regarding vector A and vector B. So they have given the dot product of two vectors is equal to 0 and the cross product of the same two vectors is equal to 0 vector. So first thing, vector A dot vector B is equal to 0 means, as I said, there are two possibilities. These two are 0 means either vector A is equal to 0 vector or vector B is equal to 0 vector. Or else, suppose if it is non-zero means, what is the other condition? It is nothing but vector A, it is perpendicular to vector B. So this is the another condition. They have given same thing, that the cross product of two vectors, that is vector A and vector B only, is equal to 0 vector. Suppose the cross product is 0 means, again there are two possibilities. Either vector A is equal to 0 vector or vector B is equal to 0 vector. Suppose it is not equal to 0 means, then what? Vector A is parallel to vector B. But with our common sense we know that, suppose this one is vector A and this one is vector B means, suppose vector A is perpendicular to vector B means, then vector A cannot be parallel to vector B. That is, this is not possible. Either these two vectors are parallel or perpendicular. So simultaneously a vector cannot be perpendicular as well as parallel, because they have given that vector A cross vector B is equal to 0 vector and dot product of the same two vectors is 0. So to satisfy this one, simultaneously these two things is not at all possible. If it is perpendicular means, then it cannot be parallel. If it is parallel means, then it cannot be perpendicular. So clearly these two conditions are removed out. So the remaining thing is this one. So what we can give conclusion regarding vector A and vector B is nothing but either vector A is equal to 0 vector or vector B is equal to 0 vector. Suppose if it is the condition, that is vector A is equal to 0 or vector B is equal to 0, only in that time dot product of two vectors is 0 and the cross product of two vectors is 0 vectors. So this is regarding the sixth question. So the next question is, if either vector A is equal to 0 vector or vector B is equal to 0 vector means, then we are saying that the cross product of two vector is a 0 vector. What about the converse statement? Suppose if the cross product of two vectors is 0 means, whether that implies vector A is equal to 0 or vector B is equal to 0. So we need to check whether the converse of the statement is true. Suppose if it is false means, we need to justify it. So clearly, if vector A cross vector B is equal to 0 vector mean, what does that implies? Vector A is parallel to vector B. So I will consider the two vectors, that is vector A and vector B, has like this. Suppose if I take vector A has 2i cap plus 3j cap plus 2k cap and vector B is nothing but 4i cap plus 6j cap plus 4k cap. So these two are parallel vectors. How I can say these two are parallel vectors? You can clearly see that vector B is equal to 2 times the vector A, because vector B, for this vector I have multiplied by 2. So when any vector is some lambda times of vector B means, then their two vectors are parallel, as I said in the beginning itself. If you didn't came across this, didn't glancing it means, go through that previous in the beginning of the vector algebra. So I am using that one to get to write any two random examples for the parallel vectors. So now vector A and vector B are parallel, we know that. So first thing, I need to find vector A cross vector B. So what is vector A cross vector B? I cap, j cap, k cap, 2 3 2 4 6 4. Expanding this one along the first row, I cap, it is nothing but 12 minus 12 minus j cap, it is nothing but 8 minus 8 plus k cap, it is nothing but 12 minus 12. So clearly it is 0 I cap plus 0 j cap plus 0 k cap. so which is nothing but 0 vector. So clearly vector A cross vector B is equal to 0 vector. So I have considered beginning itself. Suppose vector A cross vector B is equal to 0. So I need to check whether vector A is equal to 0 vector or vector B is equal to 0 vector. So I have considered vector A. So first let us find the magnitude of vector A. It is nothing but 2 square plus 3 square plus 2 square, which is nothing but 4 plus 9 plus 4, which is nothing but root 17, which is not equal to 0. So magnitude of vector is not equal to 0 means clearly vector A is not equal to 0 vector. Then similarly for vector B, magnitude of vector B, it is nothing but 4 square plus 6 square plus 4 square. It is nothing but 16 plus 36 plus 16, which is nothing but root 68, which is not equal to 0. So clearly vector B is also not equal to 0 vector. So when vector A cross vector B is equal to 0, it does not imply vector A is equal to 0 or vector B is equal to 0. So clearly converse of the statement is false. So converse of the statement is false. So this is regarding the 8th question. So here the 9th and 10th question, which is similar type of question, I have already solved in the previous video. So what the question here it is saying is we need to find the area of the triangle when the vertices of the triangle is given. So if I call this one as triangle ABC, our A is 1 1 2 and B is 2 3 5 and C is 1 5 5. So how we can find the area of a triangle? So area of a triangle is equal to half into a cross product of any two adjacent side. You can consider any two. Suppose if I consider vector AB cross vector AC, if I consider these two as adjacent side, means first find what is vector AB, then find, sorry no, it is a magnitude. First find vector AB, then find vector AC. After finding vector AB and vector AC, take the cross product of vector AB cross vector AC. After finding the cross product, you will going to get a vector. Take the magnitude of that vector. So after taking the magnitude, substitute in this equation, that is star, that is area of a triangle. You are going to get area of a triangle. So this is a hint regarding the 9th question, how to solve it. Next is find the area of a parallelogram whose adjacent sides are given as vector A and vector B. So already they have given you the adjacent side. So what is the formula to find the area of a parallelogram when adjacent sides are given? It is nothing but magnitude of vector A cross vector B, where A and B are adjacent sides of parallelogram. So they have given you the adjacent sides already. So first find vector A cross vector B. After finding the vector A cross vector B, find the magnitude of the, take the magnitude of that vector. That itself is the area of a parallelogram. So how to solve this step by step is clearly explained in the previous video. Suppose if you didn't get to solve this one, please go through that video, understand how to solve these questions, and then try to solve 9th and 10th question by yourself. So this is some of the exercise which you need to solve it by yourself. So this is regarding the exercise 10.4 regarding the vector product. Suppose if you have any doubts regarding any of the question, you can ask me at any time. Suppose if you have doubts with the any of the explanation regarding any of the questions, because here two questions are there which is some bit not different from the rest of the thing, where you need to think something bit more. So if you didn't get those questions, means you can ask me at any time. I will give you the explanation properly once again. That's all guys. Thank you.